Welcome back to the deep dive. Today, we're zooming in, getting microscopic to explore the fascinating world of human tissues.
Ooh, tissues.
Yeah, you sent over this really interesting excerpt from a textbook about them.
Yeah.
And get this, tissues are even more complex than individual cells.
Wow.
I know, right? They're like building blocks, but on a whole other level.
Right.
So the textbook actually dives into four primary types of tissues:
Okay.
epithelial, connective, muscle, and nervous. But we're going to focus on the first two today: epithelial and connective tissues.
Sounds good.
So to kick things off, epithelial tissue forms the covering and lining of all your surfaces, both inside and out. So like skin.
Yeah, it's like our body's first line of defense against the outside world,
Exactly.
protecting us from, all the elements, bacteria, all the harmful stuff out there. But it's not just a passive barrier. It also regulates what gets in and out of the body.
Oh, okay. So it's like a beekeeper
Yeah.
deciding who gets VIP access and who gets turned away at the door.
Exactly. And to do that, it needs to be pretty tough, well organized,
Right.
made up of these tightly packed cells, very little space between them.
To create a strong continuous barrier.
Yeah.
But wait, if those cells are packed in so tightly, how do nutrients get through?
Good question. Epithelial tissue actually doesn't have its own blood vessels. It gets nutrients through diffusion from the blood vessels in the underlying connective tissue. Yeah. Think of it like a sponge absorbing water. The nutrients pass through the basement membrane, which is like this thin foundation layer,
Okay.
and into the epithelial cells.
Clever. So no need for a direct blood supply.
Right.
What else makes epithelial tissue so special?
Well, it has this amazing ability to regenerate.
Oh, okay.
It's got all these hardworking stem cells in the basal layer, the bottom layer attached to the basement membrane, that are constantly dividing to replenish the tissue.
That makes sense, especially for something like skin, which is constantly exposed to wear and tear.
Exactly. Think about how quickly a cut heals. That's epithelial tissue in action.
That's amazing. It's like our skin is constantly shedding a layer of dead cells, but we never even notice.
Right. And there's even more to it. Epithelial tissue cells actually have distinct top and bottom surfaces.
Okay.
We call this polarity.
Polarity.
Yeah, it's like they have a sense of direction with each side, specializing in different functions.
So it's not just a flat sheet of cells. There's like a definite top and bottom.
Absolutely. The apical surface, the one facing the outside world or an internal cavity, often has these special features,
Mm-hmm.
like microvilli for absorption or cilia for moving substances along.
So cilia is kind of like this little oars sweeping mucus and debris out of your respiratory tract.
Precisely.
And what about the bottom, the one attached to the basement membrane?
That's called the basal surface, and it's all about, anchoring the epithelial tissue to the underlying connective tissue.
Yeah.
It's the glue that holds everything together.
Okay. Strong, directional, and well anchored.
Yeah.
What else is important to know about the structure of epithelial tissue?
Well, epithelial tissues are actually classified based on layers and shapes. So the simplest type is um, simple epithelium.
Simple.
Yeah.
Yeah.
It's just a single layer of cells.
Right.
This is found at places where diffusion is key, like the lining of the lungs or blood vessels.
Makes sense. Thin and delicate for easy exchange?
Right. But then for areas that need more protection, like our skin,
Yeah.
that's where stratified epithelium comes in. It's multiple layers of cells stacked on top of each other.
Like a brick wall.
Exactly, like a brick wall. And speaking of skin, the outermost layer is actually dead cells packed with keratin, which is this tough protective protein.
So our skin is literally built on a layer of dead cells. Kind of morbid, but also incredibly cool.
It is, isn't it?
Uh,
And then you have this tricky one called pseudostratified epithelium.
Okay.
It looks layered because the cell nuclei are at different heights, but all the cells actually touch the basement membrane.
It's like an optical illusion in the tissue world.
Exactly. It's often seen in the respiratory tract, with those cilia on its surface helping to sweep away mucus and debris.
Okay, layers check. Now what about shapes?
So we've got three main shapes of epithelial cells: squamous, cuboidal, and columnar.
And each shape relates to a specific function.
Exactly. Squamous cells are flat, like tiles, perfect for areas where rapid diffusion is needed, like the lungs.
Yeah.
Cuboidal cells are more cube-shaped and often involved in secretion or absorption, like in the kidneys.
All right.
And columnar cells are tall and slender, often found lining the digestive tract, where they play a role in absorption and secretion of mucus.
So epithelial tissue, it's tough, adaptable, highly sensitive barrier.
Right.
But the textbook also mentions glands, which are formed from epithelial tissue.
Yeah.
What are those all about?
Glands are like tiny factories that produce and secrete substances that the body needs.
Okay.
We could broadly classify them into two types, endocrine and exocrine glands.
So what's the difference?
Well, endocrine glands are the ductless glands. Yeah, they release their products, called hormones, directly into the bloodstream.
So they're like the body's internal messaging system.
Precisely. Regulating everything from growth to metabolism.
Got it. So what about exocrine glands?
Exocrine glands are connected to the epithelial surface by ducts, these little tubes that carry the secretions to their destination.
Okay.
They produce a wide range of substances, like sweat and saliva, to digestive enzymes and mucus.
Oh, wow. That's quite a diverse portfolio.
It is. And there are even different ways that these glands release their products. Merocrine glands, for example, use exocytosis, a process where tiny vesicles fuse with the cell membrane to release their contents. Think of it like a tiny package delivery service within the cell.
Okay, interesting. What other delivery methods are there?
Well, holocrine glands are the more dramatic ones.
Dramatic.
Yeah, the entire cell ruptures to release its secretion.
Whoa. Talk about going out with a bang.
Yeah, it's a bit like a self-sacrificing explosion, but don't worry, those cells are constantly being replaced.
Right, of course.
The textbook actually uses the example of sebaceous glands. Those are the ones that produce sebum, the oily substance on our skin.
Oh, yes, sebum. So that oily sheen you might see on your face is actually made up of dead cells and their secretions.
Exactly.
Okay, that's both gross and fascinating at the same time.
It is, isn't it?
So we've got these glands, and then the textbook also mentions intercellular junctions.
Yeah.
Intercellular junctions, what are those?
These are specialized connections between epithelial cells.
Uh-huh.
They're essential for maintaining the tissue's integrity and controlling what passes through. Imagine them as specialized snaps or stitches that hold the cells together.
Okay, so they hold the cells together tightly.
Right. Are there different types of these junctions?
Yeah.
There are a few different types, but the one I really want to highlight is the tight junction.
Tight junctions.
Yeah, it's like the ultimate gatekeeper. Tight junctions force substances to go through cells rather than between them.
So these tight junctions are essential for making sure substances don't just kind of sneak between cells.
Exactly.
They force everything to go through the cells, and that gives epithelial tissues that awesome power to control what gets in and out of our bodies.
Exactly. This selective permeability is crucial for maintaining a stable internal environment and protecting our bodies from harmful substances.
Wow, it's incredible how these tiny structures play such a big role in keeping us healthy. So we've covered a lot about epithelial tissue, its characteristics, its functions, and how it's classified. But before we move on to connective tissue, what stands out to you so far about epithelial tissue? What surprised you the most?
Well, it's just amazing how adaptable epithelial tissue is.
Adaptable.
Yeah. The same basic building blocks can create everything from the delicate lining of our lungs to the tough protective layers of our skin.
Yeah, it's incredible how they can create such diverse structures with the same basic components.
Exactly. Like having a set of Legos that can build a spaceship or a castle, all depending on how they're arranged.
That's a great point. Epithelial tissue is definitely a master builder.
Yeah, it's incredible how they can create such diverse structures with the same basic components.
That's a great point. Epithelial tissue is definitely a master builder. But speaking of building blocks, let's shift gears a bit and talk about connective tissue.
Okay, connective tissue.
Which the textbook describes as the most diverse and abundant tissue type in the body.
Wow.
I know, right? It's responsible for support, protection, binding things together.
Right.
Kind of like the body's internal scaffolding and packing material all in one.
Yeah, that makes sense.
But how is connective tissue different from epithelial tissue? I mean, they both seem to be involved in, like, holding things together.
Well, you know how epithelial tissue is all about those tightly packed cells? Connective tissue is mostly made up of something called the extracellular matrix.
The extra what now?
Extracellular matrix, it's the stuff between the cells.
Okay.
So it's less about the cells themselves and more about the environment they create.
Oh, okay. So it's like if epithelial tissue is a bustling city, connective tissue is a vast open landscape.
Exactly. In epithelial tissue, the cells are the stars of the show. Okay. But in connective tissue, it's the matrix that sets the stage.
Okay, I'm intrigued. What exactly is in this extracellular matrix? Like, what makes it so special?
Well, think of it as a complex ecosystem with three main components: cells, protein fibers, and ground substance.
Okay, so let's start with the cells.
Okay.
The textbook specifically calls out fibroblasts as the most common type in connective tissue proper. What do they do?
fibroblasts are like the master builders of connective tissue.
Master builders.
Yeah. They produce those protein fibers and the ground substance that give the matrix its unique properties.
Oh, so they're not just hanging out passively, they're actively shaping their environment.
Right.
It's like they're laying down the foundations and constructing the framework for the entire tissue.
Exactly.
So fibroblasts are the master builders. What other cell types are part of the crew?
You've got adipocytes, also known as fat cells. They're like the energy storage specialists, packing away lipid reserves when the body needs them.
Makes sense. It's always good to have backup energy, right? What else?
Then there's macrophages. They're kind of like the security guards of connective tissue, constantly patrolling, looking for anything foreign or harmful, like bacteria, debris, even damaged cells. And when they find something suspicious, they engulf and destroy it.
Wow, so they're like tiny garbage collectors and immune warriors all rolled into one.
Exactly.
So we've got fibroblasts, adipocytes, macrophages.
Yeah.
What about mast cells? I think the textbook mentioned those too.
Oh, my cells. They're like the alarm system of connective tissue.
The alarm system.
Yeah. They release histamine, a chemical that triggers inflammation, bringing in reinforcements from the immune system to deal with any threats.
Okay, so we've got a pretty diverse crew of cells working hard to maintain the integrity and defense of connective tissue.
Right.
What about those protein fibers you mentioned?
All the protein fibers, they're like the structural backbone of the tissue.
Okay, tell me more.
There are three main types of protein fibers in connective tissue: collagen, elastic, and reticular fibers.
Okay, I've definitely heard of collagen before. What makes it so special?
Collagen is incredibly strong and resistant to stretching. It's the most abundant protein in our bodies. It provides tensile strength to connective tissue, helping it withstand pulling forces.
Ah, so it's what makes things strong.
Yeah, imagine it as like the steel cables holding up a suspension bridge.
Makes sense. We definitely need that kind of strength in places like tendons and ligaments.
Right, exactly.
Okay, so collagen is strong. What about elastic fibers?
Elastic fibers are all about flexibility and resilience. They can stretch and recoil like rubber bands, allowing tissues like skin, lungs, and arteries to return to their original shape after being stretched.
Oh, okay, that makes sense.
Yeah.
So collagen's the strong one. Elastic fibers are flexible.
Sure.
What's the deal with reticular fibers?
The reticular fibers are like a delicate, supportive net. Yeah, they're thinner than collagen fibers, and they form this branching network that provides support and framework, especially in organs like the spleen and lymph nodes.
Oh, okay.
Imagine them as the internal scaffolding that holds these delicate structures together.
So we've got strong, flexible, and supportive fibers, but we can't forget about ground substance.
Right, ground substance.
What is that exactly? It kind of sounds mysterious.
Yeah, it's the non-living material that fills the spaces between cells and fibers in the extracellular matrix.
Okay.
It's mostly water, but it also has proteins and carbohydrates that give it a gel-like consistency.
So if the protein fibers are like the scaffolding, is ground substance just empty space?
It's definitely not empty space. Think of it like the jelly in a fruit salad.
Yeah.
It surrounds all the fruit, which are the cells and fibers, providing support and cushioning.
Okay.
And it acts as a medium for the diffusion of nutrients and waste products between cells and blood vessels.
So it's not just filling space, it's an active participant in the tissue's function. So we've got this intricate interplay between cells, fibers, and ground substance, all working together to create the unique properties of connective tissue.
Yeah.
But just like epithelial tissue, there are different types of connective tissue, right?
Absolutely. The textbook categorizes connective tissue into three main groups: connective tissue proper, supporting connective tissue, and fluid connective tissue.
And how are those different? What makes them unique?
Well, connective tissue proper is the most diverse group. It includes everything from loose connective tissue, which is flexible and good for packing and cushioning, to dense connective tissue, which is strong and resistant to stress.
Okay, so loose and dense, that makes sense.
Right.
What makes loose connective tissue so loose?
Well, loose connective tissue has fewer fibers and more ground substance, giving it a more flexible, gel-like consistency.
Okay.
It's found all over the body, surrounding organs, nerves, and blood vessels, providing cushioning and support.
So it's kind of like the body's packing peanuts, protecting delicate structures, and filling in the gaps.
Exactly. And within loose connective tissue, there are three main subtypes:
Subtypes, okay.
areolar, adipose, and reticular connective tissue.
Okay, so let's start with areolar. What's it like?
Areolar connective tissue is the most widespread type. It's like the all-purpose connective tissue found just about everywhere. connecting different tissues and providing a pathway for nerves and blood vessels.
So it's like the basic versatile one.
Exactly. Then we have adipose tissue, which is basically fat.
Ah, yes, the one we all know and sometimes love to hate. What's its main function?
Adipose tissue is fantastic for insulation, cushioning, and storing energy.
Okay.
It's like the body's cozy blanket and emergency energy reserve.
Right, got it. And lastly, what about reticular connective tissue?
Reticular connective tissue is all about creating a supportive framework for organs like the spleen, lymph nodes, and bone marrow.
Hmm,
Like a delicate but strong net that holds these soft organs together.
okay, got it.
Yep.
So loose connective tissue comes in these three varieties, each with its own special role. But what about dense connective tissue? It sounds like it's built for strength.
You got it. Dense connective tissue has a higher proportion of fibers, especially collagen, and less ground substance, making it much tougher and more resistant to pulling forces.
Okay.
It's like the heavy-duty construction material of the body.
Makes sense. So where do we find this dense connective tissue? What kind of jobs does it do?
It forms structures like tendons and ligaments, which need to withstand strong pulling forces, and it also makes up the dermis of your skin, giving it strength and resilience.
Wow, so it's all over the place, providing strength and support where we need it most.
Exactly. And just like loose connective tissue, dense connective tissue also has different subtypes.
Okay, hit me with the details.
Well, first we have dense regular connective tissue, which is all about strength in one direction.
In one direction.
Yeah, its collagen fibers are arranged in neat, parallel bundles, like the cables in a suspension bridge.
Oh, so strong, but only in one direction?
Right. Then there's dense irregular connective tissue.
Yeah.
Its collagen fibers are arranged in a more random, interwoven pattern, providing strength in multiple directions.
So it's strong in any direction you pull it.
Exactly. This makes it ideal for structures like the dermis of the skin, which needs to withstand stretching and pulling forces from all angles.
Got it. Dense regular is like a steel cable, and dense irregular is like a tough woven fabric.
Exactly.
Okay, what about the third type?
That would be elastic connective tissue, which has a high proportion of elastic fibers, giving it the ability to stretch and recoil like a rubber band.
Okay.
You'll find this type in structures that need to expand and contract, like the walls of large arteries and the vocal cords.
Got it. So we've covered connective tissue proper in both its loose and dense forms.
Right.
What about the other two categories, supporting connective tissue and fluid connective tissue?
Supporting connective tissue includes cartilage and bone.
Oh, the heavy.
Yeah. They're the big players when it comes to structural support and protection. Cartilage has a firm but flexible matrix, making it great for shock absorption and providing a smooth surface for joints to move on.
Okay.
Bone, on the other hand, has a solid mineralized matrix, making it incredibly strong and rigid.
Right. Cartilage and bone, two essential players in the skeletal system.
Yeah.
But what makes them different from connective tissue proper? I mean, they're all about connecting and supporting, right?
Well, the key difference lies in the nature of their extracellular matrix.
Ah,
Cartilage has the semi-solid matrix, giving it that firm yet flexible quality, and bone, on the other hand, has a solid calcified matrix.
okay. Different matrix, different properties.
Yeah.
Now, what about the different types of cartilage? I think the textbook mentions three: hyaline, fibrocartilage, and elastic cartilage. What's the difference between those?
Hyaline cartilage is the most common type. It's smooth and glassy, providing a low-friction surface for joints. Think of it as the default cartilage, found in places like the nose, trachea, and the ends of long bones.
Okay, so what about fibrocartilage?
Fibrocartilage is the tough guy of the cartilage family.
The tough guy, huh?
Yeah, it's packed with collagen fibers, making it incredibly strong and able to withstand a lot of pressure.
Oh, wow.
You'll find it in places that need extra durability, like the intervertebral discs in your spine.
Oh, right. So it's like the shock absorber of the spine?
Exactly.
Got it. What about elastic cartilage? It sounds like it's built for flexibility.
You got it. Elastic cartilage is rich in elastic fibers, giving it the ability to bend and snap back into shape. It's found in places that need to maintain their shape while being flexible, like the outer ear.
Oh, that's cool. I'm going to try bending my ear right now.
Yeah.
It's amazing how it springs right back into shape.
Yeah.
Okay, so we've got hyaline, fibrocartilage, and elastic cartilage.
Right.
What about the different types of bone? The textbook mentions compact bone and spongy bone.
Yeah, compact bone is the dense, hard outer layer of bone that gives it strength and support.
Okay.
And spongy bone, despite its name, is actually quite strong. It has a more porous honeycomb-like structure, which makes it lighter than compact bone while still providing strength.
So even within bone, there's this incredible level of structural diversity.
Exactly.
It's fascinating how our bodies are designed with such precision.
Yeah, it's pretty remarkable. And we haven't even talked about fluid connective tissue yet.
Fluid connective tissue.
Yeah. The textbook gives the example of blood.
Wait, blood is considered a connective tissue.
Yeah, it might seem strange.
Yeah.
But blood actually meets all the criteria for connective tissue. It has cells, it has an extracellular matrix, plasma,
Okay.
and it connects different parts of the body, transporting oxygen, nutrients, hormones, and waste products.
So even though it flows, it's still considered connective tissue.
Exactly. It's like a liquid highway system that keeps everything connected and functioning.
Right. That makes sense.
Yep.
The textbook mentions red blood cells, white blood cells, and platelets as the key players in this liquid highway system.
Yeah.
What are their roles?
Well, red blood cells are like the delivery trucks, carrying oxygen from the lungs to every corner of the body.
Okay.
White blood cells are the immune system's soldiers, patrolling the bloodstream and protecting us from invaders.
Gotcha.
And platelets are the repair crew, rushing to patch up any leaks in the blood vessels to stop bleeding.
So blood is like a bustling city with all these different cell types all working together to keep things running smoothly.
Precisely. It's a reminder that even seemingly simple things like blood are incredibly complex and essential for life.
Yeah, it's really quite amazing. So we've covered a lot of ground today exploring the incredible diversity of connective tissue, but before we move on to the final section of this textbook excerpt, the one that focuses on tissue change and aging,
Right.
what are some of the key takeaways that stood out to you about connective tissue?
I think what's really fascinating is how diverse connective tissue is. You've got everything from the flexible areolar tissue that cushions our organs to the tough tendons and ligaments that hold our bones together.
Right. And even blood. Who knew blood was a connective tissue?
I know, right? But the textbook also mentions that tissues aren't static. They change over time.
Oh, that's right. It's like they're not just stuck in one form forever.
Yeah, tissues are dynamic, constantly responding to what's going on around them, both inside and outside the body.
Like remodeling a house, you might need to reinforce a wall or add an extension.
Exactly. Tissues can do that too.
So, how do tissues change? What are some of the ways they adapt? The textbook mentions metaplasia, hypertrophy, hyperplasia, and atrophy.
Right, those are just some fancy words for different types of tissue transformations.
Break them down for me.
Okay, so metaplasia is when one mature tissue type transforms into another. Yeah, it's often a response to stress or chronic irritation, like, remember how we talked about those delicate ciliated cells in the trachea that sweep away mucus?
Yeah, those were the pseudostratified columnar cells, right?
Exactly. Well, in smokers, those delicate cells can get damaged by the constant irritation from smoke.
Oh, right.
So to protect itself, the tracheal lining can undergo metaplasia, transforming into tougher stratified squamous cells.
The kind we find in our skin.
Yeah, more like what you find in your skin.
So it's like the tissue is trying to adapt to a harsh environment by becoming more resilient.
Exactly. It's not exactly a healthy adaptation, but it shows how adaptable tissues can be.
It's fascinating, though. Okay, so that's metaplasia.
Yeah.
Then there's hypertrophy and hyperplasia, which both sound like growth.
They are. Both are forms of growth.
What's the difference?
Hypertrophy is when individual cells increase in size.
Oh.
Think about what happens when you lift weights.
Yeah.
Your muscle cells get bigger and stronger, but the number of cells stays the same.
Right, so it's like each cell is pumping iron and bulking up.
Exactly. Hyperplasia, on the other hand, is an increase in the number of cells. So it's like making more cells to handle the workload.
Okay, so hypertrophy, bigger cells, hyperplasia, more cells. Got it.
Right.
What about atrophy? That sounds like the opposite of growth.
It is. Atrophy is a decrease in tissue size or cell number. It can happen due to disuse, like when a muscle shrinks from lack of exercise, or it can be part of the natural aging process.
It's like the use it or lose it warning.
Exactly.
So our bodies are constantly remodeling and adapting throughout our lives. It's amazing how dynamic our tissues really are.
It is. And just like any complex system, sometimes things can go wrong.
Oh, right.
The textbook mentions neoplasia,
Neoplasia.
which is uncontrolled tissue growth that can lead to the formation of tumors.
Right, so tissue change is often a normal, healthy thing, but sometimes it can go awry and lead to health problems.
Exactly. And speaking of aging, the textbook also talks about how our tissues change as we get older.
Yeah, what happens to our tissues as we age?
Well, as we get older, our cells become less efficient at repairing damage and maintaining the extracellular matrix.
Okay.
And this can lead to all sorts of changes like thinner skin, weaker bones, slower healing.
It's like the wear and tear of life starts to catch up with us. Our tissues just aren't as resilient as they used to be.
that's a good way to put it. But even though aging is inevitable, we can make choices that support healthy tissue function throughout our lives.
Oh, absolutely. Like good nutrition, regular exercise, avoiding smoking, that can all help slow down the aging process.
Exactly.
Wow, we've covered so much ground today, from epithelial tissue to connective tissue, glands, junctions, different types of growth and change, even aging.
It's a lot to take in.
It is, but it really highlights the amazing complexity of the human body, even at the tiniest level.
Yeah, makes you appreciate how all these different cells and tissues work together to keep us alive and functioning.
It does. So the next time you look in the mirror, remember, you're not just seeing skin and bones. You're seeing a symphony of tissues, each one playing a vital role.
That's a beautiful way to put it.
It's true. Well, that's all the time we have for today's deep dive.
Okay.
But hey, now that you know more about how tissues work, I wonder what questions you have about how they might be affected by disease or injury.
Interesting question. I'll have to give that some thought.
Maybe it'll even spark your next deep dive. Thanks for joining us on this exploration of human tissues, and we'll catch you next time on the deep dive.